7.5a, we're talking about properties of logarithms. And what we've learned about a logarithm so far is when we talk about logarithms, we're talking about exponents. And so we remembered from an earlier lesson that when you're finding a logarithm, you're finding the exponent, right? So logarithms aren't the same thing as exponents, but they're very closely related. And so before we start into some of the problems, it says expand each logarithm, I want to talk about exponents for a second. So let's go back in time and remember some things that we know about exponents. So if I had a problem like this, we'd have x to the third times x to the fourth. All right. You should be able to tell me what that equals because you remember some of the properties of exponents. All right, and maybe you can and maybe you can't. You know, one choice would be, is it x to the 12th or is it x to the 7th? All right, but if you think about x to the third, that's this. And if you think about x to the fourth, that's this. It makes it clear, since there are 7 of them, that if I multiply x to the third times x to the fourth, I would get x to the 7th. So the rule seems to be that when you multiply two powers, you add the exponents. And you know, that's kind of an important thing. All right, there's some kind of link between multiplication and addition here. They're not the same thing, obviously, but when you multiply powers, you're adding the exponents. Multiply powers, you're adding the exponents. So then if I gave you another example, if I said, you know, b to the 5th times b to the 6th, you should be able to quickly tell me that's b to the 11th power. That's kind of the rule, and you should have learned that rule in Algebra 1 class, and it maybe came up in Algebra 2 before, but anyway, that's definitely a rule. And since logarithms are talking about exponents, we're going to have that rule. Logarithms and exponents are inverse operations of each other, and so it's going to kind of go backwards. So in this problem, when we're talking about multiplying, we end up having to add. But in logarithms, it's going to go backwards. When we're talking about adding, we're going to end up having to multiply. Okay, so we're kind of going back and forth between multiplication and addition. All right, so there's another problem. Let's say we have a problem like x to the 10th divided by x to the 2nd. Let's say we've got division this time. All right, we've got division this time. And so, you know, a very common thing would be 10 divided by 2 is 5. And so you'd say that's x to the 5th, but that's not how it works. That's not how this problem works. X to the 10th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And x squared is xx. All right. To me, it looks like cancellation. And I know that I can cancel 2 of those x's, and I'm left with 8 of those x's. And so this answer would actually be x to the 8th power. X to the 8th power. And so there's some kind of link between when we divide powers, we subtract the exponents. All right, and that's very similar to the rule above, where we multiply, we add, we divide, we subtract. Those are very common problems that you see in algebra class. So then if I give you x to the 20th divided by x to the 13th, it doesn't matter that I can't divide 20 by 13 because I'm just going to subtract anyway. I look at it as canceling. I'm canceling, I'm going to get 7 leftovers. All right, x to the 7th. That's how that rule works. And then there's one other rule that we see a lot. It looks like if I had x to the third to the fourth, okay? It's called power of powers. If you take a power and you raise it to another power, power of powers rule. And so people get super confused here about what to do because the rules seem mixed up, and you multiply, you add, and you divide, and you subtract, and this one, well, you know, this one kind of does maybe more of what you'd think because you've got number, parenthesis, number, and we've talked about that before. Number, parenthesis, number, you usually multiply. But if you think about what x to the third to the fourth means, x to the third to the fourth means you've got x to the third four times. You've got x to the third to the fourth. X to the third to the fourth looks like that, and there are literally 12 of them now. So when you're looking at a problem like this, you're going to get x to the 12th because we multiply. And so when you've got power of powers, you multiply the exponents. And so when you see that again, you're going to see another problem, and it's going to say something like x to the 7th to the 2nd. And you should be able to quickly recognize that's going to be multiplied, and that's going to be x to the 14th. You've got those three things that happen kind of a lot. Now, there are other things that could happen, but those are the main three rules that come up with exponentials. All right, so you need to remember those three things as we go into logarithms and properties of logarithms, because that's how everything works. All right, so let's go back and let's pick up some of these problems. Okay, expand each logarithm. So expand, when they say expand, it literally means to make larger. Think about the meaning of that word. Expand means to make larger. I've got one logarithm here, all right? I've got one logarithm, and if you go back and think about those rules I just talked about, this multiplication, do you remember what multiplication was linked with? Addition. Okay, we're kind of going backwards. Multiplication is linked to addition. And so what's going to end up happening on this is we're going to call this log of x plus log of y. All right. So when we were talking about exponents, when we multiply and we add, right? Isn't that what happened? When we multiplied powers, we added the exponents. It's kind of the same exact rule as that first one. When we multiplied the logarithms, we we changed to addition. So we've got that link, and that's it. That's all we're doing. So you look at number 3, and which one of those three things does that look like? Does that look like multiplication? Does that look like division? Or does that look like power of powers? Okay, well, that's the power of powers. Okay, that's the third one that I talked about. And so that's where we're going to have to multiply. Now, once you get into these problems, you're not going to think back to those rules, those things that I just showed you. You're going to do something more like this. This is going to be multiplied in the front. It's going to look like 2 times log of x. All right, 2 times log of x. That power of powers turned into multiplication. All right, that's it. That's the rule. Let me see. Okay, now this one has a lot going on. Okay, there's a lot going on because we see a couple of things. We see division, and if you go back to those rules, when we divided, it changed into subtraction. You remember that? Division was subtraction. So this division is going to be subtraction. So we could call this log base 2. That 2 doesn't really do anything, okay? But you have to put it. You can't just get rid of the log base 2 of x to the 4th minus log base 2 of y to the 5th. That division is subtraction. Okay, that division changes into subtraction. But then we have that second thing that we just saw where we've got this exponent. This is power of powers. And that exponent is going to wrap around to the front. And so to simplify this, we're going to put 4 log base 2 of x minus, and guess what? This is going to do the same thing. It's going to go around to the front of this log. 5 log base 2 of y. I should have said log base 2 of x. Now, do you think it's possible to skip that black step and go straight to the red step? If you are able to do that, go for it. I would. I think you can do this in one step if you understand that that exponent 4 on the top, that's just going to go around to the front, and that exponent 5 is just going to go around to the front, and the division turns into subtraction. All right, next one. We've got multiplication, and so multiplication changes into what? Addition. So basically, since there are 2 multiplications, we're going to have 2 additions. And so I'm going to have this, I'm going to have a log base 8 of a plus a log base 8 of b plus log base 8 of c cubed. Okay. Expand means make bigger. I literally am making the problem bigger, but there's one more thing that I'm going to need to do. Does anybody know what? The 3. What am I going to do with that 3? Yep, that 3 needs to go right there. And so again, if you can see that and do that in one step, I'm okay with that. Log base 8 of a plus log base 8 of b plus 3 log base 8 of c. Make sure you don't skip the base 8 part. That's kind of important. It tells you what type of problem it is. All right, number 9. It's the same thing. We've seen this now, right? We know that the division is going to be subtraction. And so we can say log base 3 of u to the third minus log base 3 of v to the third. But then we're also going to have to take care of these exponent 3's. That's going to go around to the front. 3 log base 3 of u minus, take this one to the front, 3 log base 3 of v. Expand. Expand the logarithm. Now, honestly, expanding a logarithm does not help you out as much as the next problem when we get into the next set of problems where it says condense, okay? A lot of the times when we want to condense, it's because we're trying to solve an equation. So they're trying to prepare you for solving really complicated looking logarithmic equations. So condense, we're just going backwards now. All right, think about the front side of this page and what we did to get this number in the front, this 4 in the front. This 4 in the front was multiplication, and it came from that exponent right there. So condense, I'm trying to make the problem smaller. I'm going backwards. I'm reversing. That came from log x of, or log x to the 4th. And now the next one, we see a plus sign. And plus sign was linked to multiplication, right? All right, plus sign was linked to multiplication. So we're going to condense into a single logarithm, and we're going to say u times v, like that, all right? And again, that problem, what that's good for, or what that's going to be good for, is we're going to have to solve equations. And so getting it into a single log is going to be really important for us. Once you get the hang of it, something really complicated looking like this is going to be simple. All right. So think about what's going to happen with this 3. It's going to go back here and be an exponent, right? And what's going to happen with this 18? Same thing. It's going to go back here and be an exponent. And also, what's going to happen with this minus is division, right? So we can do all of that at the same time if we want. I mean, I can do it in 2 steps, but you can probably skip a step and go and go straight to the final answer if you want to. So if I just do the red part, again, this is not how I would do it. Log base 9 of a to the third, and log base 9 of b to the 18th. That's what happens with those reds. But we know what's going to happen with that subtraction. That subtraction is going to make us divide. And so we can condense into a single log, base 9, and we're going to divide. A to the 3rd over b to the 18th. And again, if you are able to go straight to the answer, I think you probably can, and I'm totally okay with that. So number 17 looks really complicated, right? That's a big logarithm, and we've got to do a couple of things. So I see some pluses, and I know pluses are going to change into multiplication. So I'm going to have log base 3 of x times y times, so yeah, what's going to happen with that 6? Thanks, sir. Thank you. Thank you. Thank you, everybody. Yes, today is my birthday. Super old. Super old. Yeah, plus a lot. Okay. Back to the math here. What's going to happen with this 6? It's going to go back. Oh, I know. It's going to go back to that exponent. Z to the 6th. That's going to be z to the 6th right there. And that's it. That's the answer. All right. I like blue. All right. So number 19, you got the same kind of deal. You've got this 2 is going to go back to the exponent. This 6 is going to go back to the exponent. And what's going to happen with the plus? Multiplication. Very good. So log of u squared times v to the 6th.